Okay, we'll go back to our review. So we'll go to the second problem, right? Sodium oxide and water. Okay, so you have to write down the correct formula. Sodium oxide, hopefully you know how to do that. Yes?
For the first one, why couldn't we product with Na2O and then H2?
Say it again. Why you only one?
The first one you said that the product was NaOH and H2, right?
Yes.
Why couldn't it be Na2O and H2?
Say the words. Say the name of it.
Sodium oxide.
Sodium oxide?
Yeah.
Well, you will know why now, in a few seconds. Okay?
Right.
So, sodium oxide and water. What will that give you? Again, you visualize, because you see, when I was an undergraduate student, actually what's happening in Greece too, the way I was taught the two series was not really, many times we just memorize things. We didn't really ask why this are important. Why? And then when I went to organic, I thought organic and inorganic is two different things. No, it's not two different things. The principles are the same. We just simply did not do this job when we were doing the two series, and then organic was just like a new thing. It's just literally the way we're doing it. If we do it the right way, it's smooth. There's no like pull, you know. So, what do you write down? Sodium oxide is an ionic compound. You know that, right? Instead of memorizing, you recall what you know already. Sodium oxide is an ionic compound, and this is 2 minus charge. Yes, minus charge. I don't put oxidation numbers on ionic compound. 2 minus, and sodium is plus. Okay? These are non-oxidation numbers. They're actually real charges. And then you have water, which is actually, you can write it like this, just for the sake of preparing yourself to see what will happen. Okay, well, oxygen 2 minus from 2B is a very, very strong base, Lewis base. When you go to organic, you will call it nucleophile. Just the word changes. The function, the property, there's no change. You will just call it nucleophile. It's the Lewis base. What's the big deal about it? You know how it behaves. You know what it does. If you call it a different name, who cares? You will call it nucleophile when you go to organic. So that's a strong Lewis base. Or it can actually be said that it's extremely strong Bronsted-Lowry base. It's a donor of a pair of electrons, at least one pair of electrons. So it's a Lewis base, but also it can accept a proton, right? And can act as a Bronsted-Lowry base, strong Bronsted-Lowry base. Do you have an acid there, according to Bronsted-Lowry? That is a donor of protons. Yes, water is a Bronsted-Lowry acid. Weak, but when there is a very strong base, it says weak. No, weak, I don't care, I'm strong. Gravity, right? So you will have a proton transfer from the water to there, and if that happens, or this picks up this proton from here, right? And all this is going to be a minus, yes? So what is going to happen? O2 minus with H plus is going to become what? And this that remains is what? And what else does it remain? 2 sodium plus. So what do you think the product is? Interesting, isn't it? You see? By understanding the chemistry, you can predict the product instead of becoming a pattern. Just to memorize things and to repeat things like a machine, like a zombie. We are not zombies. We are not zombies. We are thinking creatures. Okay? And we need to develop that instead of memorizing things. Okay, did you enjoy it? Yes. If you need to, you will. You don't have to worry. You don't have to worry about it. Okay. Let's go to the other one because it's very similar. So now your question has been answered, right? You will not put sodium hydroxide because you can see sodium oxide is not stable. It will react immediately with water. So it will not be a product. In the presence of water, it will not stay as sodium oxide. Somebody asked, right? You got it? Yes? Yes. Okay. So now let's go to the next one. Let's go to sodium peroxide, water. So now you should remember now what's the peroxide group, right? What does the peroxide group look like? Well, you have the peroxide ion, which you know it's like this. And then that needs how many sodiums? Okay, that's sodium peroxide. In fact, you can visualize it like this. Yes? Again, if you remember Lewis structures, it's like this. So when you react this one with water, this is the same like before. This is a Bronsted-Lowry base. That oxygen base acting as a Bronsted-Lowry base. Can pick up a proton. And in fact, you have two of them, so this one picks up this proton, goes away, and this one picks up the other proton, goes away. Isn't that? Yes. True. Or you can actually, because you see, if you pick up one, the second one is not easy to pick it up, right? Can you see what I'm saying? One proton goes away from water, becomes what? Minus. To pull another proton is very hard. H2O is much stronger acid relatively to OH minus 1. It's a much stronger Bronsted-Lowry acid. That's kept to be African. Yes? So instead going for the second one, actually, he's going to go and pick it up from another molecule of water. This one is going to go and pick up this. Okay? And that's plus, and this is going to be minus all this. So what do you see? From each side, it's going to give you what? Which is hydrogen peroxide. Yes? Plus, you have 2H minus from here created. And you have the two sodiums there, so it's going to be two sodium hydroxide. Isn't that neat? Pretty cool, huh? Can do B chemistry. Bronsted-Lowry acid with Bronsted-Lowry base. Proton transfer reaction. And then what remains is hydroxide with a sodium plus will be sodium hydroxide. Isn't that cool? This is the way chemistry should be taught and should be learned and should be asked to be understood, not memorized. Okay? Did you enjoy it? I did enjoy teaching it to you. Did you enjoy learning it? Yeah. At the end, I will go over it again at the end. Okay? Because we need to cover more problems. Okay, let's go to the next one. Let's go to number 14. Okay? Let's go to number 14. So when you study, how many hours do you study continuously without break? How many hours? Say the numbers. 8? 3. 2. Half. Anybody else? 1. Anybody else? 45 minutes? 45? 4 to 5 hours continuously? No break? If you are not producing results, maybe you should try to take more breaks in between. I mean, you know, just take breaks, make it shorter. Right? Whenever you feel like frustrated, tired, stressed out, just get up, do some movements. Take a little ball like this, knock it to your head, knock it on the floor, listen to some music, makes it a little bit, walk around. Take some tea, go and sit again. We have to know how to do it. to know how to do it, not just, it's not happening. It's not happening like this. You have to go with the flow, with the wind. We don't go with the wind, we break. How many people get sick near midterms? You know how many people get sick? Their stamina is going all the way to zero. The immune system says, I cannot go along with you because you are silly, you are stressed out for no reason. That's what the immune system is telling us. And it doesn't matter how many drugs, medicine, you know, pain relievers, or what. It doesn't matter how many we get. The more we get, the worse will become. Because they have side effects. So don't come to take an exam with all this stuff because they have side effects. And you will become like a zombie. You will not be able to think. You don't need this stuff when you take an exam. Neither caffeine, coffee, or tea, or whatever. Eliminate these things when you take the exam. Otherwise, this does not work properly. It's not just study, study, study. It's really how you're doing it. More important. Really. Are you ready? Okay, now, for the first one, it says, so here you actually need to remember the complex, the coordination number, how much it is. You just have to remember it for that to open door. The same thing with y. You have to figure out, so, first of all, you should know what aquaregia is. Okay, aquaregia, remember the definition, is a mixture of concentrated hydrochloric acid together with concentrated nitric acid. Two strong acids concentrated, a mixture of them. In a ratio, by volume, 3 to 1. 3 HCl, 1 nitric acid. And the way you can remember this is because you have a lot of HCl, three times more than nitric acid by volume. The complex that forms is not a nitrate complex, it's a chloride complex. Actually, the nitrate is not a good ligand. So it should be there then. You can see it. It's a chloride. You see the chlorine there, the chloride. Okay? More HCl, 3 to 1, you get a chloride, a gold chloride there, right? What's the coordination number? Anybody remembers? 4. Okay? Now, what is Y? That's what kind of nitrogen oxide you get from this reaction. It's a redox reaction when you use aquaregia. Aquaregia has what in it? Concentrated nitric acid. And there's somewhere there in the reader, it says, and we said that in the lecture actually, that what an oxidizing agent, in this case nitric acid is oxidizing agent, is giving you, what will be its reduced form is going to be nitrogen oxide or nitrogen dioxide. Will nitrogen go to +4 or nitrogen is going to go to +2 from +5? Not only depends on what it reacts with, in this case gold or whatever, but it depends also on, one word, on conditions. So, if the nitric acid is acting as the oxidizing agent and it's concentrated, it goes to nitrogen dioxide. When nitric acid, the strong acid, right, acts as an oxidizing agent and it's dilute, then it is reduced to nitrogen oxide. So Y should be what? Y should be what? Equal to what? Then, according to this statement. What's the number of Y? 2, right? This is a redox reaction, right? The nitric acid is the oxidizing agent oxidizing from gold from 0 to gold what? If it's 4 there, it's going to be +3, right? This X is 4, then gold goes to +3, from 0 to +3. So gold is actually oxidized by aquaregia. It cannot be oxidized by just nitric acid or just by hydrochloric acid. But if you put the two together, 3 to 1, then you can oxidize the gold. Right? Okay, so you already know these answers here because of what we said, right? So x will be what here? X equal to? Is equal to? X is equal to? Are you guys, did you fall asleep or something? X is equal to what? Dilute nitric acid with copper. What's the number x? 1. And here it's going to be 2, right? How about this? Phosphorus with limited quantity of oxygen. Well, you know phosphorus reacts with oxygen, right? Which kind of phosphorus? White or red? White. White, which is in the form of tetrahedral, molecular substance, right? The white phosphorus is molecular substance. The element is in the form of molecules. P4, tetrahedral, right? And it's very reactive because the bonds are weak. Yes? And it reacts with oxygen, gives you an oxide of phosphorus. Now, limited or excess makes a difference. When you have excess, you get an oxide that will have more oxygen per molecule, right? When it's limited, it's going to have less. So do you remember the formula? How do you remember it? You have the tetrahedral, 1, 2, 3, 4, P4, yes? And then for every edge of the tetrahedral, when you have a tetrahedral, how many edges do you have? 6, yes? The tetrahedral, 1, 2, 3, 4, 5, 6. 6 edges. And for every bond, PP, there is an oxygen insertion. So you have how many oxygens? 6. So it's going to be P4O6. And then when you have more oxygen to react with, then oxygen is going to go also on phosphorus, like, remember, in each corner there's an oxygen, and there's 4 corners, so it's going to be P4O10. Yes? Okay. Do you want me to continue, or you are feeling tired and you want to go home? Because it's kind of hard to really do it when there are people sitting like this. There's no energy here, no energy. You will go home, and then I don't know how you will do your exam, or how you're going to do in the other exams of this quarter. Where's your excitement? Where is your joy? Where is the strength? Where is it? What has happened to you? You're youth. Your blood should be boiling. This man is almost 60 years old. Your blood should be boiling with excitement and joy. Looking into the future, doing what you love. Where is that joy? Where is that life? Where is it? Who's taking it away from you? Something is taken away from you. You can regain it. Regain it before you get sick. Regain it. Throw your worries away. You're free. You do not know it. The Great Spirit is taking all your needs. You're scared. There is a power that will take care of your needs, whatever they are. It doesn't matter where they are. You've got to trust. Steve Jobs said you've got to trust something. Your guts, your center, karma, whatever. You've got to trust something. You cannot succeed unless you trust something. Trust yourselves. You don't trust yourselves enough. That's why you're moody. You don't trust yourselves. You trust things from outside. You have to trust the things from within you. It's the incredible power inside you. The whole universe lives inside you. You must find it. Connect to it. You will never be afraid of anything. When are you going to do that? You want me to continue solving problems, or you will be like this? When I ask questions, why don't you answer? Are you afraid that you will have the wrong answer? And what other people are going to say that I'm not good enough? Are you thinking that way? Say it loud. 2, 1. Collaborate a little bit. So we can go on. Just make an effort, right? Come on, you guys, you can do it. You're all beautiful. You are all lights, perfect, divine, pure love. But acting like this. Our mind is tricking us what we are. So, on the final review, fake it. You don't feel like clapping your hands when they sing? Fake it until it becomes real. You got it? Okay, here is a problem. Very interesting. Do 15. Try to do 15. You will have a similar one in your exam, I think, if I remember well. Yeah. Okay? Try to do 15. Have you done this problem before? Yeah? Yours? Okay, great. I think there's a similar problem. You will have lines, you know, so you will be able to see the relative heights to be correct answer, right? So you have lines on your notebook, you have lines, so you can use the lines to do it correctly, okay? By using the lines on your the page of your notebook, because you need it to make it, you know, easy. Are you really sorry? Why? Why would you be sorry? No one can hurt us except our own selves. That's what Buddha said. Buddha said that. No one else can hurt us except our own selves. It's very challenging up there. Did you do it? Did you do it, you guys? Okay, let's see how you're going to do it. If I show you the solution, you will not really get it. I have to do it slowly with you. Okay, so what does it say? It says energy. What kind of energy? Entropy. So here is entropy. Yes? And then it says the reaction is a three-step reaction. So immediately I know that it's going to look like this. 1, 2, 3. I'm going to have three hills, three mountains. Yes? Each step has a mountain, a transition state. So the first thing you have in mind is this. I have a three-step reaction, so I'm going to have a thing like this. And then it gives me details about the energies of the... Let me try to save some paper, but it's not a good idea right now. So it's going to be like this, look. 1, 2, 3. Yes? Three-step reaction. Each step has a transition state, reactants, products, transition states, 1, 2, 3 steps, intermediates, and activation energies. Activation energies, actually, there are 6. Why? First step, activation energy is this. Forward reaction. A to B, B to C, C to D. Forward. 3 activation energies. The first one, the second one, and the third one. Can you see that? Huh? A to B, I mean the reactant. Reactant to, let's say A to B, B to product. Okay? 3 steps, simple things. Each step has a transition state. There is two intermediates. It's always x minus 1. X is the number of steps. X minus 1 is the number of intermediates. You can see from here, for 3, it's 2. Two intermediates, three transition states, reacting to products. And then each step has two activation energies. Why? Because there is actually, each reaction is reversible, theoretically speaking. So it's going to be like this. Each reaction is going this and goes like that. Reversible, right? So, activation energy is 3 for the forward reactions, A, B, B, P. But then we have activation energies the other way. In other words, the activation energy for the reverse reaction for the first step, which is from here to there, and therefore the activation energy is going to be from here to there. That's activation energy, 1 reverse. And then for this step, the reverse, here is the reactants, here is the products. For the second step, the reverse reaction, so it's going to be from here to there. So this is going to be activation energy for the second one, reverse. And then for the third step, the activation energy for the reverse step, here is the reactants, here is the products. For that step, it's going to be from here to there, and it's going to be EA reverse 3. So we have 6 activation energies, 3 forward, 3 reverse. For each step 1, we have the reactants and the products, we have the transition states and the two intermediates. Shoot? Shoot. Now, we need to consider B, C, and D, what they're talking about. So what does it tell us? It tells us that the enthalpy of the product is the same as the of the reactant. So this, look, this and this should be on the same height. So it's not correct. It should be there, not there. It should be there. Okay? Then what is telling us? Activation energy of the first step, forward reaction, first step is reversible. Okay, so that activation energy is equal to the activation energy of the third step reverse reaction. So we have this activation energy first step forward equal to what? Third step reversible equal. So this and this this one here this is not correct. This is going to be from here to there, right? That will be the wait a minute. No, wrong. For the third step, reverse, activation energy is going to be from here to there, right? So it's going to be, this is the reactants, this is the products, here's the transition state, this is going to be actually this one here. Sorry, this one was wrong, right? The red was the reverse, right? The red we put reverse. Okay, let's review it, make it right. Okay, so reverse is going to be activation energy from here to there. That's correct. Reverse for this step, reverse. Here's the reactant, here's the product. So from here to there, this is going to be the red activation energy. Nobody corrected me. Nobody. And for the third step, the reverse is going to be reactants, products. Activation energy is going to be from here to there. That's going to be activation energy of the third step reverse. Nobody corrected me. These were wrong. So yes, that these two, activation energy of the forward, this, right? First step forward, and activation energy of what? The reverse third step, which is this, and that, this, blue, and this red should be equal. And then what else? Enthalpy of the intermediates is the same. So this and that should be on the same line. So this one should go a little bit up like this, not down there like this. So the intermediate energies of the intermediates should be equal. Everybody got it? And if you take that into account and you draw it now by taking this from just sloppy, now you know how to do it, then you draw it, right? So So you can do it on your scratch paper this way, and then you put it, now correctly, it should look like this. Good? Of course it's true. Very true. On purpose made that way to be symmetrical. Beautiful. Huh? Yes? Isn't that beautiful? Yes?
Does the middle have to be more positive necessarily than the other two measures? Because let's say you integration of whatever you do at the same height.
No, it doesn't. It can be, usually it's up. Almost all the time it's up. If it goes down, probably the reaction will stop. The intermediates you're talking about, the energy of intermediates, yeah. Almost all the time they're higher. But sometimes they can be lower than the reactants of products, okay? But so it doesn't matter how you do it. You want to bring them down, you can bring them down, yeah. That's correct too. Okay? It doesn't have to be, but it has to be symmetrical, right? Plane of symmetry, huh? Okay. Any other question? Okay, let's see what you want to do now. Any questions you guys have? But when somebody asks, please, the rest ones, they should not talk. If you talk, we cannot do anything. More or less I'm done, but if you have questions, I will go over them. But with the requirement for the 10 minutes, the requirement, when somebody is asking a question, please, the rest don't start talking, even if it's chemistry, because we cannot make it happen, okay? Just listen to the question, and then wait for the answer from another student or from me, but not talking, please. Okay, so any question, bring them forth. And don't start getting up to go until you have to go to the bathroom, because if everybody starts slowly, one by one, to go home, then everybody, you know, this is not a class, this is chaos. Then it becomes like chaotic. Just hold your horses for 10 minutes. For God's sake, 10 minutes. Unless you have to go to the bathroom, please go. 10 minutes. Respect your schoolmates. They might have a question. Give them the chance. And at the same time, you probably don't know the same question, and you will have the answer too. Come on. These are very basic stuff. Yes. Loud, please. Explain what? D? Okay, so the letter D says that the intermediate's energy, enthalpy, specifically, right, is the same. So, as you can see, first step, before the chemical species, that it is the product of one step, and the reactant of the second. This is the product of the first step, and reactant of the second step. Can you see it? Okay, so the chemical species is reactant of the first for one step, and product of one step, and the reactant of the next step is called intermediate. Yes? So this is an intermediate. The other intermediate is this one. There's two intermediates. Okay, the energy of the enthalpy should be the same, so that's why they have to be on the same line. Now, somebody could draw it like somebody else said there, that you could draw it like this, look, like this. Or it could go even right here, right there. Like this, right? Still they're equal. And if the other things are obeyed by doing it, I think they are, right? It's okay. Okay? So, all right. Anybody else? how to do that? B. Well, let's suppose story is one going to the end. Just to write the problem and read it. The simple question, short questions. We cannot go over a whole problem right now because we don't have time. Short questions, okay? At the end we'll go over the board. When you mix sodium peroxide with water. Okay, sodium peroxide is what? Is an ionic compound, right? Sodium peroxide. You remember the formula? If you don't remember it, at least you know peroxide, how it looks like. And that's an anion. If you have sodium, together with an ion, it's going to be an ionic compound because sodium is electropositive. So if it's -2 and sodium has always +1 as cation, then you need 2 of them. That's why you go and put sodium 2, right? +2. The charge of sodium is +1, right? Times 2 + 2. The charge of this is -2, right? -2, okay? So basically it's like this. You can say like that. You can see it like this. Yes? You can see it like that. So this species right here is acting as a Bronsted-Lowry base from both sides, because each side has 3 electron pairs, and you need only one, at least one, to pick up a proton. Yes? So the peroxide group, like this, is acting as a Bronsted-Lowry base, picking up protons from each side. So it picks up a proton from one water, picks up a proton. The water is acting as a Bronsted-Lowry acid. A water molecule gives a proton, right? Here is a water molecule, gives a proton, and the rest becomes OH minus. And that proton goes into one of these and becomes OH. The same thing happens from here. Another water molecule gives a proton, and that proton is picked up by this and spits out an OH minus. So you have hydrogen peroxide, right? This with 2H pluses from each side will give you hydrogen peroxide, and then you have 2 hydroxides generated with a 2 sodium plus will make you 2 sodium hydroxide. You don't have to memorize. You can use common sense and some chemistry you already know, and it becomes really interesting to learn chemistry. I'm not going to teach chemistry anymore. I'm going to become a medical doctor. I don't need chemistry. I don't need to understand them. I just want to memorize them. Okay? You can try it that way. You can try it that way. Each one tries his own way. He thinks he's best. The best way he thinks, right? If you think that's the best way, go ahead. But the teachers are paid not just to give you letters and equations. Teachers are also paid to coach you, to mentor you, to give you advice how to navigate in college life and after college, to make it easier for you, to be more successful. Not just to make grades, just to, but in general, to think really correctly, logically, for your best interest. And you should be very happy when you see teachers like this around campus, because there's quite a few of them. And when you find them, follow them, listen to them. Their words will benefit you. Any other question? And that will be the last one. Any other question? Something you didn't understand from the problems we covered? I wish you good luck.